When we start to solve one-step inequalities, we want to generally follow these steps. We want to solve the inequality, making sure we flip the inequality sign if needed, and we'll talk about what that means. If we have time, it's always a good idea to check the solution. And then last, because it's an inequality and there's not a single number answer, we want to make sure we graph our answer on a number line. As we start solving inequalities, there's that one main difference between an inequality and an equation. And that is that if you multiply or divide but by a negative, then you have to flip the inequality sign. And then as I'm looking through here, I'm seeing a couple different negatives. I'm seeing a negative 10. I'm seeing a negative 3. A bunch of negatives on the bottom. Just because there's a negative in the problem does not necessarily mean you're going to flip the inequality sign. So let's look at a few examples, and then we can see when we do flip the sign and when we don't need to. So in this first one, we're going to use inverse operations. So the opposite of plus 5 is minus 5. So we minus 5 on each side, just like as with an equation, to make this 0. So x, yes, there is a negative. However, I did not multiply or divide by that negative. We're just subtracting, so the sign stays the same. And then 5 minus 5 happens to be 0. So just a quick graph, I put 0 in the middle and count 1 on either side. Because it is a greater than, it does not have an equal to, so I want an open circle. And greater than, I'm going to shade to the right. This middle one on top, the 2 and the x are being multiplied when they're next to each other. So the opposite is to divide by 2, divide by 2. So we are dividing on this one, but we have to really look at what are we dividing by. We're dividing by the 2. The negative 10 is just getting divided. So even though there's a negative sign here, we don't need to flip the sign. And again, that is because the number we're dividing by is the positive 2. So then x is less than or equal to negative 5. So again, that's an example where there's a negative in the problem, but it's not going to affect our sign because we're dividing by the positive 2. So a quick number line, I'm going to put negative 5 in the middle, and I'm going to count 1 on either side. This time it does have the or equal to part, so I'm going to fill in that circle. I want values for x that are less than, so less than I'm going to shade to the left. Third one on top, that fraction bar means I'm dividing, so I'm dividing by negative 3. The opposite is to multiply by negative 3. Now here's where we're going to change that inequality, because what are we multiplying by? We're multiplying by a negative value. And anytime we multiply or divide by a negative, we're going to flip this around. So instead of less than, it's going to become greater than. And again, that is because we are multiplying by negative 3. And then 8 times negative 3 is negative 24. So I'll put negative 24 in the middle. And then I'll put 1 on either side. Oops, negative 23 and negative 25. It does not have the equal to sign, so open circle. X is greater than, so shade to the right the numbers that are greater than. First one on the bottom is, this is where we tend to have some errors. We see this plus sign and automatically want to do a minus. But that plus sign is actually with the x. We're trying to get rid of the 7, and the 7 has that minus sign with it, or the negative sign. So the opposite of negative 7 is positive 7. And I can tell because a negative 7 and a positive 7, that is going to make 0. If I had put just another negative 7, that would have been negative 14, and that's not what I want. And then I don't really need to bring that plus sign down because x is just x. I don't need a positive sign in front of it. It's already positive. We are not multiplying or dividing by a negative, so that sign's going to stay the same. Negative 4 plus 7 is 3. So I'm going to put my 3 in the middle. Count 1 on either side. This one does have the equal to part, so I'm going to fill in that circle. Values for x that are less than, so I'm going to shade to the left, less than. This middle one here, we tend to get confused with some fractions, so I want to make sure we looked at some fractions. This fraction is very similar to the one right above it, where that 2 is right next to the x, they're being multiplied. Well, that fraction is right next to the x, they're being multiplied. So the opposite is to divide by negative 3/4. Or if you remember that dividing by fraction is the same thing as multiplying by the reciprocal, then you are welcome to go ahead and do that. I'm going to go ahead and say we're dividing by -3/4 to make those cancel each other out, because that makes 1. Here's another common mistake. The variable, the x, is on the right-hand side. Make sure you're bringing that straight down so it stays on the right-hand side. I did divide by a negative, so this inequality sign needs to flip around. And this is why it's important to bring everything straight down, because if I had accidentally put the x on the other side, my inequality sign is not going to be the correct sign anymore. So make sure you bring everything straight down. X comes straight down to the right side. We flip that inequality because we divided by a negative. And then we're going to do 12 divided by -3/4. You can put that in a calculator. I'm going to do it by hand here. So we do keep the first one, change to multiplying by the reciprocal. And then I can multiply straight across, or I can reduce first. And we get -16. Now when I make the number line for this, we can leave it like this, but we have to be careful because with the variable on the right-hand side, we can't just follow this arrow. So instead, I want to rewrite this. So I'll flip the x over. But when we do that, we have to be very careful. Notice that the large side was facing the x before. Make sure the large side still faces the x. And then those two are equivalent inequalities. So I'm going to put -16 in the middle. It does not have an equal to part, so we're in an open circle. And now that we have the variable on the left, now I can just follow this red arrow and say I'm going to shade to the right. Another way you can check is if you take any value, so I shaded towards a -15. If you plug in a -15 in place of x and check and see if the statement is true, is -16 less than -15? If yes, we shaded in the right direction. If no, we shaded in the wrong direction. And our last one, we are adding 1/4, so the opposite of adding is to subtract, so we're minusing 1/4 from both sides. Remember, one's from the left of the inequality and one's from the right. This makes 0. Everything has to come straight down, so the x comes straight down. I did not multiply or divide by a negative, so that sign is going to stay just as it is. And then 7/8 minus 1/4. Remember, when we're doing adding, subtracting fractions, we have to have a common denominator. So I can make this into -2/8 by multiplying everything by 2. Or you could put it in the calculator. So I have 7/8 minus 1/4 in the calculator, or by hand, 7/8 minus 2/8 going to be 5/8. And just like the one before, that x is on the right-hand side. We tend to make mistakes if we leave it there. So I'm going to flip it around. The big side's facing the x. Make sure the big side still faces the x. And there's our equivalent inequality. So I'm going to put 5/8 in the middle, and then 6/8 and 4/8, or 1/2. And then it does not have the equal to part, so another open circle. And x values that are greater than, so I'm going to shade it to the right.